Right. Hi, I'm Colin. How many of you, is this your first time in Code Supply? Cool, great. We always like to see new faces, and we always like to have people come back. I'm trying to think of upcoming events that are going on. This week was our real big week for June. We had 3 meetups this week. This is the third 3 this week.
Fundraiser.
Oh yeah, fundraising. So in July, which is July 7th, we're doing a summer soiree for the Code and Supply Scholarship Fund. It's a donation event. Donate some money, come get some great food from, I believe we're getting it from Mad Mex. We'll have drinks at the Frick Museum. So it'll be partially outdoor, partially indoor. We'll give it 4 parts of the museum. There'll be music, probably some games.
Van Gogh. Monet. Degas.
I don't know what it. Like, are there paintings there? Oh yeah. I forgot about Frick Museum has various well-known artists' paintings. Come and see some cool stuff. Tickets are available on codeandsupply.fund. That's the website for the scholarship fund. The scholarship fund. How many of you are familiar with the scholarship fund? A couple? Okay. I'll give a quick pitch there. So the scholarship fund was founded in 2016 after the success of the scholarship program at Abstraction, where we were able to bring 57 people from all over the world to Pittsburgh to come to the conference. We started up this nonprofit that will fund conference experiences, people to come to Pittsburgh to go to a software conference. Or if somebody gets accepted to speak somewhere outside of Pittsburgh and they live in Pittsburgh, we'll act as kind of the funder of last resort for them to be able to actually go to that conference. We funded, I think we're up to 12 people so far this year. We sent a whole bunch to RailsConf, or I should say brought in a whole bunch for RailsConf. We brought in a few for Artifacts, and we're working on getting some other partner conferences to participate as well. So please do check that out, codeandsupply.fund. Donate if you can, come to our party. It'll be a really good time. Absent anything else I can think of that's like Code and Supply meta, other than we are a co-working space. How many of you knew we were a co-working space? Okay, just about everybody. Then I'll skip that mostly. But we do have space available if you're interested in picking up capacity. And without further ado, hello. We'll have Seamus Johnson talking about the cloud on the computer. The laptop's little cloud.
You might have to click that. I got it.
Got it? Okay. All good?
Yeah.
All good. Okay, I am so thrilled that you all came out to listen to me squeeing about my favorite operating system. Thank you to Code and Supply, Justin, Colin, et al. For hosting. If any of you felt comfortable moving up to the front seats, I would really enjoy that. No pressure if you don't. I like a slightly cozier crowd, that's all. Awesome, thank you. Okay, so disclaimer: I'm not an expert. If you go home and brick your laptop, I'm sorry. If I say something that you know is wrong, please speak up. It's how we learn. And if you ask a really interesting question, you might get a deer in the headlights look. What is an operating system? Everyone in the room can answer that. I'm very sure, but we might all give slightly different answers. So a baseline for this talk, it's a collection of code that tells hardware how to function. It's something that sits between the computer that you as a developer or user interact with and the hardware underneath. That's a hypervisor. A type 1 hypervisor is like an operating system. It sits down there on the hardware, bare metal. The only things beneath it are the BIOS, the firmware for the devices, that sort of thing. And it, unlike a traditional operating system, it runs other operating systems instead of programs. A type 2 hypervisor is, it's an ordinary program. You install it on your computer and it runs operating systems. Paravirtualization is a mode in which the operating system, for example, if you make a system call that's going to read from a file on the disk, and so it has to go out and access the disk. In modern Linux kernels, the system call will be a wrapper that will, if it detects that it is being virtualized, that the kernel is being run by a hypervisor, it will call to the hypervisor and let the hypervisor handle accessing the disk. Otherwise, it will try to access it itself. In full virtualization, the OS has no idea that it's being virtualized, and we'll get right back to what kind of problems that causes. Are hypervisors easy to design? No. So getting back to the system call, there are machine instructions which are sensitive and ones that aren't sensitive. Any process can run a non-sensitive instruction. The CPU will allow for that. A sensitive instruction, if it is run by something that is not in privileged mode, which would be 0, it will either trap, meaning it will return control to the thing which is in 0, or it will be silently ignored. Now, as you can imagine, the silently ignored part is a problem. And the reason that it's a problem is that the kernel, I'm speaking for Linux here, but any operating system, is not used to having its instructions ignored. So, the hypervisor puts itself in mode 0. This is for Intel architecture. The user processes go in 3, that's where they normally go, and then the hypervisor puts the kernel in 1, which is traditionally not used for anything at all. When the traps occur, that's good. When the instructions are ignored, the not good part, there's two ways that can be dealt with. One is VT, which is virtualization. That's been around since the 90s, but hypervisors themselves are a lot older than that. Hypervisors, IBM has been working on them since the 60s. Not a new technology at all. So one thing, VT, is the CPU cooperates with the hypervisor to make sure that everything that should trap, traps. In the other solution, before that was possible, is binary translation, which is basically that the hypervisor reads the code of the OS as it's running, reads ahead, and simply replaces everything that is going to be a sensitive instruction, like setting interrupts on or off, or accessing a device, and replaces that code with the code that the hypervisor wants to be there. Virtual memory. So this is really cool. The process thinks that it has the full address space. It can write to the whole thing for anything it wants, for the heap, the stack, loading files into memory, etc., etc. The OS keeps a page table which maps the virtual memory to the hardware memory, and this is how you can run programs that are actually bigger than the amount of hardware that you have, the amount of memory that you have on your machine. So what does the hypervisor do? The hypervisor keeps a page table of a page table. And modern hardware for like Intel and AMD actually will help facilitate that. I think this part is so cool. This is actually my favorite part. So this is displaying what's like a very basic default setup. The hypervisor will put the hardware, the physical network card, into promiscuous mode. So it's capturing all the traffic that comes off of the wire. It bridges that traffic to each of the running virtual machines on the hypervisor, so that each of the virtual machines can have its own IP address that is transparently visible on the network outside, or whichever network the virtual machine server happens to be connected to. And so that's a basic setup. It can get way, way more complicated than that.
Oh, I just started using VMware, and this network thing, getting your own IP address is way cool. Except it doesn't work, at least I haven't figured out how to get it to work, when you're like at Narrow or you're sharing Wi-Fi. At that point in time, you have to use NAT. So if you have any thoughts or comments along that, or you want to wait till the end, or it's not an appropriate topic to discuss, that's okay.
I certainly wish I could help you, but I don't have much experience with VMware.
Okay, fair enough.
But yes, I was just going to cover the fact that you can get way more complicated than that. You can set up network address translation. You can set up multiple virtual networks. You can set up firewalls. And this is all inside one physical computer.
Yeah, can you just like run us, because this sounds really cool, can you just like run us a little more through what's going on here? So card's in promiscuous mode.
Right, the card is on...
Like, is the hypervisor like copying all of it off each of the kernels, or is it like splitting out traffic? Or like what is it? Is it acting like a router? Like how does it work?
So in what I have diagrammed here, what the hypervisor is doing is it's trying to emulate in software the job that would be traditionally done by a bridge, or if you so what it tries to do is, if you get a packet and the packet is addressed to say 10.10.10.16, and that would be, say, this one, what the hypervisor will do is it will take it and it will deliver it right to this VM. It won't deliver it to the other ones because they don't need it.
Is it running from something like IP tables? Is it like where you get IP level, or like, or is it like, is it just Ethernet?
Well, it really depends on which hypervisor you're talking about. So I'm focusing on Zen, and Zen is based off of Linux kernel, I believe, but is heavily modified. And so yes, it's using a routing table. It's using some modified version of IP tables, I'm fairly sure.
Yeah. I'm just curious. I'm just like, this is cool.
Okay. Okay, yes. So it can do firewalls. It can actually pair hardware network cards together so that the virtual machine thinks it's talking to a single network interface. In reality, it's passing traffic along multiple network interfaces for more bandwidth and for high availability. so much for that. Were there any other questions before I move on to the next section? Okay. What about Docker? The next few slides are just clearing up some stuff that is adjacent to hypervisors and virtual machines, and sometimes gets kind of confused, which is perfectly understandable. A virtual machine is an operating system. It has an operating system. It boots up like a true computer. A container is a file system. It's like a directory with files in it. Docker takes advantage of some kernel level features of Linux, which is why Docker can't run natively, for example, on Windows. C groups, namespaces, etc., to give Docker's running processes a very a boxed-in view of the operating system. If you've ever had the experience when you were a kid of making a really cool mix CD and putting your MP3s onto your CD drive, but not clicking burn until you're sure that you have the right files, the right order, that's how Docker does its union file system, essentially. What about Vagrant? Vagrant is very similar to Docker in a certain sense. It's an abstraction. Docker is an abstraction over Linux kernel features. Vagrant is an abstraction over virtual machine providers, hypervisors, as we just covered. It's very cool. You can also use Vagrant with Docker images. If you're like, I want to use Docker, but I like Vagrant's interface. What Vagrant isn't is a hypervisor itself. What about Kubernetes? Kubernetes is an orchestrator. If your thing crashes, it brings it up. If you have too many things, it gets rid of some of them. Too few things, etc. There's three concepts that are kind of useful for putting it in context with virtual machines. Kubernetes has nodes. Nodes, if you're running, for example, on Google Cloud, or basically any other cloud provider, the nodes are probably going to be virtual machines. On the nodes, the pods, and inside the pods, the services. The things inside the services could be virtual machines. There's adaptations for that, but are typically going to be containers, like Docker images.
So is Kubernetes like an operating system for multiple machines?
Is Kubernetes like an operating system for multiple machines? In what sense do you mean an operating system?
For example, an operating system, an operating system knows that a file is located. When you go to save a file, it knows where to put it on it knows which disk and where to put it on that disk. An operating system knows when something died. An operating system knows, hey, I've got 6 cores, so I need core, 3 has got an open slot. That's what I'm thinking.
In that sense, I would say yes, very much. Kubernetes is like an operating system for servers.
Okay, so the flip side of that, from what you said, is, in another sense, it's not, right? Because from the way you answer the question, I get the sense that it's really not an operating system.
In the sense that I don't want it to be conflated with something that you install on your laptop.
Okay. Got it.
Yeah.
My understanding is that Kubernetes is more like, my understanding, which may be incorrect or incomplete, is that Kubernetes is more like system D for multiple machines.
It's
More like system D.
system D. Okay.
So you say, I have a web server, and I have a database server, and the database has a storage server. So I want to bring up the web server, then first the database server has to be running, and it can run on these machines or this many machines. And that's cool.
That is a very excellent point. Thank you for bringing that up. Yes, what you were talking about, very much like the scheduler, the init process for. What's a virtual machine? Since I've been talking about them a lot and how they are run by a hypervisor. It's just a file. I don't really like the sort of mysterious marketing hype-driven stuff around the cloud. It's just a file. It's probably a compressed file. There's an open standards format that's been ratified by a couple of standards bodies for how that file should be written and composed. And now we get to the part of the talk that I actually wanted to get to. This is Qubes is a project which turns a type 1 hypervisor, Zen, that has historically been used by just about every established cloud provider out there into a friendly and reasonably secure operating system for your laptop. It's kind of what it looks like, or at least this is what mine looks like. Everything that I demonstrate from this point on can also be done via the command line, but I'm sticking to the GUI because I want to show that this is definitely sort of an end user operating system for a certain definition of end user. You'll see up here is the VM manager. Walk you through that. There's the name column, the state column, which shows you if it's running, if it's starting up, starting down, if it's off, if it needs upgrades from a template, which I'll get to in a sec. You can see what template it's based on. You can see what net virtual machine it's using. You can see how much of the memory it has allocated it's using. You can see what IP address it has. And you can also add tons more columns to that that I do not currently have displayed. It's a very fast way to start them up, shut them down, make changes to them. So going back to the net VM column, you see the Vault VM there has dashes in the net VM column. And what the dashes mean is that as far as the operating system in that Vault VM is concerned, it does not have a network card. It cannot talk to the internet at all. Nothing goes in, nothing goes out. You see that the untrusted VM is connected to the firewall. The firewall is connected to the sysnet, and the sysnet has NA, which means it doesn't have, means it's using the network device directly. It talks to the network card. That's where the stuff comes in and out. It's funny because I think of that one as being the completely unsafe, untrusted zone, but that's actually the level of security of every other laptop I use. And DOM0, which is the administrative domain. It's the ground zero for if you have root access on DOM0, you can make any changes to the hypervisor you want. Speaking for the Zen hypervisor here. Moving over to the template column, one way that security is enforced on it is that the only thing that persists on the virtual machine image after it's shut down is your home directory. So anything else, like a program that you want to install elsewhere, you'll need to boot up the template that it's based off of and install it on the template. DOM0 is based on the admin template. You can see all the others that I have there are Fedora. But you can use Ubuntu, you can use Windows, you can use any operating system that you're happy and comfortable with. How do you start programs? There's a start menu. You click on things. It'll start the things up. It'll start the VMs up if they're not running when you try to start a program on that virtual machine. This here is demonstrating that they are actually, the file systems are actually isolated from each other with using the date command to show that I didn't cheat. I created a file on the firewall. You can see that it's not on the untrusted VM. It's not visible from that one. And the other thing you may have noticed by now is that Qubes is a very colorful OS. It is. It's really pretty. I like that. But it's not an aesthetic choice. It wasn't done to be cute or pretty. DOM 0 runs XFCE. It used to support KDE. I'm not sure if it actually supports KDE anymore. It runs the Windows Manager. The thing that you click on, it draws them. So when it draws this, this green window and puts sysfirewall in those brackets at the top, unless there is a bug in the Xen hypervisor or in Qubes, which is always possible, I know with 100% certainty that that window, that green window there, has been drawn by that virtual machine and no others. Any of you ever had something like this pop up on your screen before? Yep. I think that slide speaks for itself. Okay, this is me right-clicking on one of the VMs to show you some more options. This answers the question of, like, how do I plug in my thumb drive and upload, download my files to it? You attach it. It can't be accessed from a running VM until you attach it. That's pretty much the same for all block devices and for audio input. So if you're running a Firefox in your untrusted virtual machine and you don't have your audio attached to it, you are pretty much 100% certain that even if there are bugs in Firefox, which there may be, or Chrome, or whatever you use, nobody is listening in on your audio. As far as that virtual machine is concerned, until you connect the audio, it has no sound card.
What about audio out?
Audio out is handled automatically by Qubes so that, yeah, sound basically plays from wherever. I think that you can lock that down if you want to, but I'm not positive. You might have noticed earlier when I showed you the start menu that there was just like Firefox and Terminal, which you're like, gee, all I can do with this operating system is browse the web. No, this is kind of a security feature. It's nice. It helps to prevent you from accidentally launching a thing you did not intend to launch on a certain virtual machine, as you can edit for each virtual machine what files are, or sorry, what programs are available in the start menu for it. Other settings you can see here. You can change what template it's based on. You can change what network virtual machine it's based on. Some more settings. You can scale up and down the memory that it's allowed to use. You can scale up and down the virtual CPUs that it's allowed to use. I mean, with the caveat that you probably shouldn't give it more CPUs than you actually have. So on this slide, you can see that I'm transferring a file that I've downloaded from Firefox to another virtual machine. It's just it's as pretty much as simple as right-click and move to or copy to. I enter in the name of where I want it to go, and you're thinking, yeah, but you see that that dialog box is in red, which means it was launched by the untrusted machine. I bet I could write a script in the background to copy files to your DOM 0 and do all kinds of fun, nasty stuff. Nobody else was thinking that? Nope. Qubes has got you. And there's the file. So that's all great, but backups must be super hard on this thing. No, not really. The this nice little thing. You click on it. You select which ones you want to back up. You tell it where you want to back them up to. You can encrypt the backups so that they are secure. You can access the files in the backups without the Qubes operating system, which is kind of critical to me, as long as you don't forget your encryption passphrase if you used one. And as you can see here, because it's not the full operating system, because it has this template structure, your VMs can be pretty small for backup. This is an overview of the architecture. This is Qubes 4, which is slightly different than what you just saw, which was Qubes 3. They're moving away from Xen. A lot of people are moving away from Xen. It's sad. AWS uses KVM now. But the idea behind their migration is that eventually it would be really awesome. Oh, go ahead.
Oh, I was just wondering, if maybe you'll get to this later. What about, how does it multiplex graphics cards?
No idea.
Okay.
Sorry.
Thank you.
Okay. I'm not going to go through this in any great deal of depth unless people had specific questions about it, because it's just another way of looking at the information that I already showed you a moment ago. You can see how the template VMs have a root image which is copied to the running VM. You can see how the networking is handled, how the peripherals are handled. You can see how the disk management is handled, how it talks to the hypervisor core, how the graphics are managed, etc. You can see here, interestingly, like in 4, they split out the graphics from DOM0 to be into a separate domain for security reasons, which I thought was a good idea. You seemed to know a little bit more about that. Is that you don't? Okay. And I said that I would tell you how to install Qubes, and I totally lied about that. I won't. If you've installed any Linux distro before, or basically any operating system before, Qubes is easier to install than any of them. And by any of them, I mean it beat out Ubuntu by a little bit. It was dead simple. If you haven't installed an operating system before, this could be your first if you wanted. Couple of caveats to mention, though. The one is that because it's based on the Xen hypervisor, it wants to have the whole disk to itself. It's not Microsoft. It won't overwrite your partition table, but it will erase the boot sector. So if you try it out, you don't really like it, you want to go back to a different OS on a different partition, you'll have to repair that. It does warn you before you do that. Second caveat being that it does not take as much system resources as you might imagine it takes, but it's not a little lightweight toy system. It requires a nicely substantial laptop, like probably any good laptop that was manufactured in the last 6 years or so. And because there are other compatibility issues, it's a good idea to check out their hardware compatibility list before installing it. Although, that said, I am currently running it on a laptop that is not on their list of compatible hardware, so you can give it a try. I mean, the worst thing that happens is it won't install, won't run, and you'll be like, well, gave that a try. So yeah, if there are any questions about it that you want heard by the whole group, I'm happy to answer them. But I won't keep people hostage who want to get out of here, so otherwise just come up with your questions.
So, Cassie, why Qubes? I mean, you seem to be really excited about this one particular operating system. What drew you to it? You can't share, that's okay.
I guess just security fascinates me at some level, and like the quest for trying to make an operating system where you can run things, where you can run different programs that you don't trust, that you just downloaded from whoever, wherever, 200 developers touching it, and be like, yeah, even if this program is messed up and malicious, I can do other stuff over here and be fairly confident that it has no way to touch them.
For example, you could run an application as root, and then it won't have access to anything
Besides the root on that single virtual machine, yes. Guy in the very far corner.
Yeah, so I was going to say, I use this, and what I use it for is I run a whole VM for each client or each open source project I'm working on. So I have isolate it's computerization of attention, all my browser tabs, my editor, it's all the stuff. I give each project a whole machine. Not because I'm necessarily worried about security, but it's just it's nice. I can come back to something that I worked on 3 weeks ago and start it up and pull it, start Chrome back up, and then just all your browser tabs over there, and then you're like, okay, shut all that. Yeah, so that's it. I've been doing that for, I don't know, maybe 6 to 9 months, and I get a janky homebrew version of this with creating a VirtualBox for a couple of years, but it never worked real good. It's got some rough edges, but it's really awesome. It's a really nice way to work.
Rough edges, yeah. That was the end users for a certain definition. I thought I saw one other hand. Yeah, I'll paste the link in. Are you on the Code and Supply chat?
Yeah.
Okay, I'll paste the link in there. Sure. Okay, I didn't know if Colin had any closing remarks that he needed to make. But,
No, not in particular.
okay, thank you all so much for coming.